So let's start. I'm going to speak today about general concept of self-healing systems and what you might or might not want to have in account when you try to design such systems and what those systems really mean. But before that, very quickly, this is me, obviously. I work for CloudBees, a company behind Jenkins, open source enterprise. And if you're using Jenkins, we're going to be best of friends. You'll see that. I work a lot with Docker as well, very closely with them. And if you're using Docker at least, in production, I knew it. Okay. I wrote a couple of books. That's about it. You don't need to know much more about me. So let's start with continuous deployment, right? Probably most of you are already doing continuous integration and you're thinking or already on a path, or maybe you're already doing continuous delivery, continuous deployment, right? And at least on a logical level, what continuous deployment means, it's relatively simple. And continuous deployment means that we provision some machines, whatever machines we need for something to run, we test it. We build some software, test it again, deploy it, test, enable it, test, right? Do a bunch of stuff, and after each step we test. Do something, test, do something, test, do something, test. So that's already mainstream. We are all at least talking about, if not doing it, and probably on a way to do it in a not so far future. No? Kind of that's almost already a past, at least for greenfield projects. But what is more often overlooked, and what people often forget to think about, is what happens after you deploy it, right? If you're capable of automating everything until it gets to production, then we equally need to think about processes, tools, and what's or not, about what's going to happen after it is in production, because that's as important or even more important as the process that puts something into production. So what we need to do really when we deploy something in production, first of all, we need to monitor that something. That's whomever, any of you that is working as operator in IT knows, we need to monitor our applications, see that they're behaving as expected, right? There's nothing new about that. We react to problems. Again, something that we've been doing for many years. Reacting to problem means usually for most of us, you get a call in 3 in the morning, get out of bed, go to the office and fix it, right? That's how we react to problems when they occur. But what is more interesting is that we are slowly becoming to think in terms of how to prevent problems from happening in the first place, right? And this is more or less the subject of what I will be talking today, how to prevent things from happening in the first place. And we can do that, not maybe entirely 100%, but we can prevent many of the things that are happening today. And another subject is how to have all that automated, right? There is no real sense, if you think about it, if you're capable of automating everything until it gets to production, and we are, simply because most of the things are repetitive, and repetitive things should be automated because they always do more or less the same thing. So why don't we think, or at least I think that we don't think enough in terms of how to automate everything that is happening in production after it's deployed. But the real problem, before I go into more details, is, I think, in the way how we approach the problem. And we usually approach the problem by trying to seek some kind of perfection, right? We sit for a long time, design our applications, we develop for a long time, we do a lot of stuff with a general plan to make it as robust as it can be, right? It will never fail because I'm going to design it to be unfailable. Which is, if you think about it, actually, if you've been working in this industry for more than a week, you know that that does not happen. Kind of like designing applications for a perfection is just a waste of time. It's a very worthy goal. We should do a better job, better to do good job than bad job. But simply, we cannot design something towards perfection. So what we are trying, at least places where I've worked, some of the companies I worked before, I get the task, I was a system architect, design this application so that it never fails, right? Design my services so that they can handle any load that you throw at them, right? And by the way, you don't have a big budget, so you cannot have 100 servers. You can have one server and make sure that it never fails and it works under any load, right? Because tomorrow in the future, and that future might be 10 years from now, we expect a huge business behind this, right? Of course, whomever coded ever made the bug, whomever tested ever found that bug. It's impossible not to. Even if you don't make a bug, unintentional bug, you can consider bug something that is not the behavior expected by client, even by user. So bugs are inevitable as well. And we try, many of you probably were one day or another involved in purchasing, those servers, 50,000 euros single server. It has hard disks and redundancy and everything. It always works, right? We do that a lot. At least we were doing that a lot. So it's almost, we're slowly starting to move towards understanding that this is more or less the waste of time. Quality is not a waste of time, but seeking perfection is, because it changes our mind and we lose focus for some things that are very important. Because applications will fail, services cannot handle any load that you put, commit, there are bugs, hardware breaks, all those things happen. So when I was thinking some time ago about how should we design systems that actually do not have those problems that we are having today, or we were having at least yesterday, my inspiration, or at least the way of thinking, came from observing life, right? I'm not a biologist, but I read just enough on Wikipedia to understand how those things work. And how life works is it has certain properties that are very important and actually can relate very much to the systems that we're trying to build today. And that one is system or individuals. Like, system is what matters. Humanity must survive. A life must survive. Any certain individual lives or dies doesn't really matter, right? What matters is the system as a whole only. Small incremental evolutionary improvements. I don't know how many of you believe in Big Bang, but most likely it was evolution. And evolution means that we change constantly in very small, almost negligible steps. Reproduction. You are all products of reproduction, so you know what that means. And self-healing. Self-healing is very interesting because we get attacked by viruses and things happen to us every day. Or any moment of our life, things are happening. It's just that our body is capable of fixing those problems, self-healing, right? Most of the time. Sometimes we die, but most other times we are actually recuperate from many viruses or things that happen to us. Most of the time. And as a system, all the time. When you think about it and when you read about it, you get to a conclusion that smallest possible piece that matters really in our bodies are cells, right? Our bodies consist of many cells, millions. And cells have certain properties that we can also relate to in what we do. And one of those properties is that it can restore itself into a state of equilibrium, says Wikipedia. What it really means is that new cells will be born, and old cells will die, but the total number of cells and what they do will be in accordance to what our body needs at any given moment, right? They will always be in equilibrium. They are monitoring and adjusting processes. Whatever is happening, when we need to run, we get more something. When we sleep, we get less of something. Things are changing all the time as a result of monitoring and adjusting our processes. Reproduction, now I don't mean reproduction how you came into the world, but reproduction that each cell is capable of reproducing itself and multiplying depending on the need. Healing. So if we translate now that into what we're doing, we get something like this. We get data center, right? A data center that would be, in this case, for example, our body or a whole ecosystem. We get some kind of orchestrator, call it a brain, that actually manages everything around and manages by itself. We don't think about most of the things that are happening. They're simply happening because brain works all the time. Microservices. That's why we're moving slowly towards microservices. Not everything is moving towards microservices, but many of the things we do are moving towards microservices simply because of those properties that you can observe in cells. And properties we're going to discuss in more details very soon. And containers and scaling. We need all those things. Containers are really interesting because with containers we get that thing. It's immutable, it's unchangeable. We cannot change what is inside of one container, but we can multiply that container to as many instances as we need. Similar like what cells do. And by multiplying those containers, we get scaling, right? And equally important, descaling. And when we combine all that together, I know that we can create a system that is capable of self-healing. A system that is capable of reacting to whatever happens to it and preventing things from happening. When I say everything, not really everything, but most of the cases, many more cases than we are actually capable of doing today, or most of us. So, in order to create such a system that is capable to self-heal itself, that system needs to change many of the processes that we are using today, and needs to change many of the tools, even that we use today, and equally much change the architecture of what we have today. Legacy must die one day. So, in order to do that, we need first to be capable to discover the problem in the first place. If you don't know that there is a problem, you cannot fix the problem. So you need to discover that, okay, there is a problem, this is a problem. And I'm talking from now on everything about machine discovering, not us. I know that we are capable of discovering the problem, but can we tell machines how to discover a problem? Can we tell machines that whenever they discover a problem, they restore themselves to the desired state? And I intentionally put here desired, not designed, because they're quite different concepts. System works as designed only the first second after we create it. From there on, the design goes through the window, because things start happening. Changing traffic, changing conditions, changing hardware. Things are happening all the time, so we don't really care anymore how we design the system. We care at any given moment what is the desired state of that system. And then it needs to be capable of combining those two things to make certain decisions and to adapt to change conditions, right? I'm going back to the same example, but there will be many more, like change in traffic load, going up and down all the time. So, when you think about how you can restore yourself into the desired state, you need to start thinking about different levels where you're going to intervene, or different levels on which you're going to design your system. And those levels are, first of all, application level. This is the part I'm not going to speak about much, because you probably all know already how to design applications that are fault tolerant, right? You know, in a worst case scenario, you know how to write try catch, right? In a better, maybe a bit more advanced scenarios, you might experiment it with messaging, with akka and many other funky stuff, but most likely you or developers working with you know how to make your system not fail too often, at least not when they're trying it on their laptops. But this is the more important, not more important, equally important, but more interesting for this speech, is on a system level. How do you monitor the whole system and decide what to do? Because individual applications, we need to trust developers that they know what they're doing, but occasionally they're going to fail, and then we need to look at the system as a whole, right? And finally, hardware. Hardware is becoming almost irrelevant today, simply because we are all moving to cloud slowly, hopefully. And in cloud, you start treating your servers like kettle, right? You know the distinction pets versus kettle? Never heard of it? Yeah, it's few of you. Meaning that most of our careers, we were treating servers like pets, right? This is my server, I give it a name, Garfield, right? And then I treat it well. I make sure that it's always well, right? That pet of mine is always in good condition, always works. With cloud, we treat them like cattle. We don't care about individual servers anymore. We care about quantity. We care that we have 100 CPUs, this much memory in total, this much hard disk. Individual servers are becoming slowly irrelevant. We're thinking about clusters, not about individual servers anymore. So those are the three levels, very important ones. But then there are different types of healing. First one is that we all use probably one way or another is reactive healing. Reactive healing means that something happened, fix it. That's the story from the beginning of this talk. 3 in the morning, get a call, go and fix it, right? It's a very bad way to do business. Especially very bad that we are expected that the uptime is close to 100%. 99.999999999%. Preventive is where I think that the industry is slowly moving towards. That means that trying to figure out how to prevent things from happening in the first place. So in order to design such a system, there are a couple of prerequisites, that, at least in my case, proved to be valid. And I think that no matter which technology you use, some of those prerequisites you might not even see because they're happening behind the scenes. Some of them you might, but no matter, they are always there, whether you see them or you don't. First of them is ability to deploy to any server inside a cluster that meets hardware requirements. What that really means is that you don't deploy to a certain server anymore. You tell your machines, I want this application deployed to my cluster. I don't care where. Not only that I don't care where, but I cannot care anymore. Because when I start scaling to 50 instances of something, I cannot say, this instance goes to Garfield, this instance goes to Mordor, this instance goes to Superman, right? You just say, deploy. And that's the only way, because our servers, as I said, are starting to be treated as cattle. They just die, and new ones come and increased, multiply, decreased. Ooh, I talked in advance. I was about to speak now about pets and cattle. You already heard it. Another thing is that a well-designed system, I think, means a system, and this is the part where operation guys tend to freak out, systems where you have no access with SSH, right? You cannot access any of your servers. You should not have a need to access any of your servers, and even if you do have a need, that should be a sign that actually you did something terribly wrong. You cannot go SSHing into 100 servers. That's, when you think about it, you need 100 people if you want to SSH into 100 servers, at least at the same time. And you need service discovery, because if you deploy to a random server, you don't know where it's going to get deployed. It's going to deploy somewhere, wherever requirements are met, wherever we have enough memory, CPU, and this and that. So you don't know where your application is going to land, right? And if you don't know where your application is going to run in advance, that means that all your configuration properties, configuration files and property files, all those things that you were configuring yourself before, that goes to trash. Right? You don't know where your database is going to run. It's going to run wherever there is space, and it's going to be multiplied when needed, so it means that you don't know where. In other words, you need service discovery. You need a mechanism that is going to monitor your system and say, oh, well, look at this. MongoDB was deployed. Store the data somewhere. Create configuration dynamically. And let somebody, whomever needs it, discover it. And there are many tools that do that. I think that today you already had a couple of talks. Consul, etcd, registrator, Consul template, confd. Those tools are popping like mushrooms. They're very easy to use. The main problem, again, is going back to our architecture. Our architecture needs to change. There are no static things anymore, and configuration is one of the first candidates to go out. So let's see number 2. Ability to deploy without downtime and to automatically scale and descale instances, right? How many of you, when you deploy a new release of something, are deploying it without downtime? Not even a microsecond. Huh? 5, 6. Excellent. 7.5, right? Again, I think that it's more because of our way of thinking and because of the size of what we have, right? Because things are big, and when you have big things, the only way to put another big thing is to replace the big thing with another big thing, right? We'll get to that. And another ability, I'll go back to downtime, is to automatically scale and descale, right? How many, you must have, let's see example, right? You have a proxy. Probably most of you have a proxy, right? Proxy. You monitor traffic through your proxy, right? I hope. And when that traffic goes above certain 10 milliseconds, 100 milliseconds, something, you just scale, right? You say, give me 5 more instances of this because people just got their paychecks and they're buying something from my site. And equally important, you need to be able to descale. Because if you're on cloud, let's say that you're on Amazon, right? Why would you pay servers running 100 instances when there is a need only for 10, right? You want to scale, you want to descale to save money. Scale to serve your users so that they're happy, descale so that you save money so that your business is happy. So in order to fix downtime, one of the two best ways that I found that I've been using is blue-green deployment. And if you're using, know what blue-green deployment is? Only a couple of you? Okay, very quickly. Blue-green deployment means that you don't replace your release 1 with release 2, boom, and say, this is now a new release. It means that you run in parallel things. Release 1, proxy is going to release 1, and then you create a new release, release 2, test it, test it, test it, test it, test it, and then everything is working, just change the proxy and kill the old one. And then you have no downtime, because at any given moment, at least 1, sometimes 2, parallel releases are running in parallel, right? Very easy to do. There is no real mystery. Again, mystery is when we have huge applications. Because if my application is occupying whole server, then I need at least 1 more server to do blue-green deployment. But when your applications are smaller, services, not to say micro, then those things become very easy suddenly. Because the process is there, it's been used for a long time, architecture is the problem, I think. Now, relative scaling is, if you used things like Mesos and Marathon, Kubernetes, Swarm even, they're very good at scaling stuff. You can say, deploy 10 instances. But what we don't want is actually precisely that. We don't want to tell him deploy 10 instances. We want to tell our system deploy plus 3. Increase the number of instances by 3, because my demand is increasing. If you need to go and check how many instances am I running now, 10, okay, 13. It's ridiculous. There is simply no time. I assume that everything needs to become as fast as it's happening in instance. So relative scaling is something that tools are slowly starting to adopt. Now let's go to 3. Monitor hardware and dynamically adjust cluster capacity. Right? For those of you, even those of you running on premise, how many of you? Premise? Less than I thought. That's good news. If you're running on premise, that's still no excuse not to have cloud. People associate cloud with public, AWS and Azure and other things. Cloud will be everywhere. And even if it's on premise, you're still going to run cloud on premise, meaning that you're going to run your servers with properties that clouds exhibit. And some of those cloud properties is to be elastic, right? When you need more servers, there are more servers. When you need less servers, you just shut down servers. No, sorry, remove applications from the server and free space for something else. You just distribute things all the time, constantly among your servers, those that you have. Those that need it more, have more. Those that need it less, have less. And then suddenly the situation changes. And monitoring hardware, we spent too much time, I think, monitoring hardware, like tools like Nagios and similar, monitoring hardware so that we fix it. No, you don't fix it anymore. It's becoming commodity. Throw it to trash, right? Because there is a new one, at least in cloud, or at least throw it to some room where somebody's fixing hardware, right? But don't try to fix hardware. It just takes too much time. And it doesn't make any sense in cloud cases. So when we monitor hardware, we react to things like, oh, I don't know, not enough disk space anymore. I'm on 98%, or CPU, or God knows what. Try to prevent. That's what I spoke a bit before. And then a fourth one. Can you monitor your services in near real time and execute reactive actions? When you think about all those things, they're not a secret anymore. We already, most of us know how to do it. We're just more scared and does not fit our architecture anymore. But can you monitor your services? And this is a very tricky one because you cannot use, for example, any of you using Nagios? Yeah, you cannot monitor it with Nagios anymore because you don't know where your services are, right? You need to use, your services are moving constantly. They're here, there, there, there. They're getting scaled, they're getting descaled. And Nagios is one of those tools from before, unless it changed recently. I'm not following it for a couple of years. That simply it has static configuration, right? You need to use whichever tool is capable of consulting your service discovery, console etcd, whatever you're using, and saying, okay, tell me what's the current situation in the cluster, and I'm going to go and check whether the current situation really is what you think it is, right? So you need to start using tools that are dynamic. Console is one of those examples, at least one when I used it, is using its own data store to discover, oh, I have 5 services, 5 instances, excellent. Are they running? Yes. Oh, I have 7 instances, next moment. Are they running? No. Do something. So monitor and do reactive actions, meaning that when a service dies, when an instance dies, you might want to do something. But be careful that if you go back to example of system or individuals, you should not care whether an instance dies anymore. Again, that's become, you should care whether the system behaves as expected, right? That's a tricky part, because if you have 5 instances running of some service, right, and suddenly one of them dies and you have 4, but if the system continues behaving as expected, if the system continues responding as fast as it should, why would you bring back that instance? You should think of the system, not of individual instances, right? So how many of them are running at any given moment, whether some died or no, is becoming irrelevant. Whether the system behaves as expected is becoming important. And the only way how the system behaves, if you have information about the system that is dynamically constantly changing, and that's service discovery. So you need to do some checks of your services as a whole all the time. Check, 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 check. Every 10 seconds, for example, would be a good period, let's say. Some of them even go much faster. And be able to redeploy your services when something goes wrong, new instances of your services. And this is again a tricky part, because going back to what I said before, you don't redeploy to a certain server. You cannot redeploy to a certain server because maybe that certain server died, right? So you need to deploy to a cluster somewhere. Stop thinking about servers, think about clusters. And when you think about deployment and redeployment, think about one big chunk of hardware, huge. So number 5, and this is the most kind of, this is the real deal. This is where we are today, I think, as an industry. It's just that the previous 4 are prerequisites. You cannot get here unless the previous 4 are already in place. And this one says, ability to predict the future and execute proactive actions, right? It's almost like looking in a crystal ball. Crystal ball, what's going to happen later on today? In order to do that, in order to predict the future and do proactive actions, we can start with very easy things, right? Easy things that do not hold water for a long time, but it's a good start. One of them is schedule scaling, right? You have your collective memory as a company, and you know that every 1st of January, people go crazy and they go to your website or whatever you're using, and there is increasing traffic, right? That's scheduled because you use your collective memory to decide, you know from experience, that something is going to happen in the future, right? We've been all doing that. But more interesting is scaling based on historical data. And there is a bullet outside, Elasticsearch, for example, is one of those, is that can you collect your metrics all the time, in real time, and put it in a database capable of holding all those metrics, and then use it to something good? And something good can be many things. For example, if your hard disk is 90% full, is that a reason to do something? We don't know without historical data, because maybe it was on 90% already for 5 months and it's going to stay there, so that's good. Or maybe it's going to reach 100 in 1 hour. And the only way to know that is to know how things were behaving in the past, right? So with which rate your hard disk was getting full. And then use that calculation to decide when it's going to get 100% and how much time the system has to do something about it. Call an API in Amazon, for example, and add in more space. Another one would be commonly At least in my case, common example would be network traffic. Let's say that you're monitoring your traffic that goes through some proxy, right? And you say response time is 1 second. That's a cause for alarm, right? Let's bring 5 more instances of our service. No, because the fact that at this very moment is slow does not mean that the next moment is not going to be fast. Because at this moment we might have had some glitch, maybe temporary something, but we need to explore what was happening last hour, right? Was during the last hour very slow, so that we should make it faster. And then once you get there, then you start doing something. Speaking too much. Then you start going more and more in paths, start evaluating. It's almost a very, very simple intelligence, saying what was happening this same day last week, this same day previous month, what was happening, what's or not, and what's or how in the past to figure out what you should do next. So now that being said, that kind of there is a clear logic about what we should do, in a way. And we know the processes more or less that we should follow. Let's see which tools fulfill those, can fit those processes, because it's very important that actually we never start with the tools, but start figuring out what we want, and once we know what we want, see which tool can be used to accomplish that same thing. One of them is cluster. First types of tools that we need is we need a cluster orchestrator. From what I spoke by now, we need a real-time registry. We need a place that we're going to put real-time data for service discovery. We need historical registry where we're going to put data from the dawn of time. We need a monitoring tool, and we need some general type of orchestrator, right? Those would be the 5 pieces, one way or another, needed in such a system. So for cluster orchestration tools, there are more than those I'm going to speak about now, but those 3 I'm going to speak about are probably most commonly used today, or at least most hyped, depending how you look at it. One is Mesos, with Marathon and all other modules and plugins that come with it. How many of you using Mesos? Oh, you shame yourself. Okay, Mesos has been around for a long time, extremely long time. And extremely long time in those things means almost 3 years. It's more or less, maybe 4, I'm not sure. But very short time in human calculation and very long time in technology-wise. It's been proven it works in production. Everybody knows that it's very robust, production ready, and probably most used one in the market today. It has a bunch of modules, and the good thing is that those of you not using Docker and containers, those of you not using containers because your management does not allow you to use containers, use Mesos. Simply because your manager will not know, but behind your back, Mesos is going to create containers without you knowing. So you're going to get into containers without knowing that you're using containers. It uses LXC from kernel and creates containers for everything you do, so that you isolate stuff. It's very good, very much used with big things like Hadoop, etc., and recently it supports Docker. Now, the problem is that actually recently supports Docker. If you're, on the other hand, into Docker and containers, or want to be in the future, then Mesos is really terrible. It's terrible simply because it's obvious that Docker and containers were an afterthought. It was never meant to run really. It was never designed to run containers, so it feels very awkward and cumbersome at moments. And the other negative thing is that it's written in Java. Now, I'm not going to trash Java. That's for another talk. No, but when you want system-level tools, not web server and stuff like that, when you want something very close to the system, you don't go with Java. You go with C, C++, and if you're very hip, you go with Go, right? I'm not saying that Java is bad. It's not bad. But for this type of tools, it's just terrible. Now, this is This is a proof that actually containers work. And simply because Google has been running containers for, I'm not sure, 8 years, something like that, give or take, right? Long before most of us even knew about what containers are, right? Just that it wasn't Docker, so that's why nobody knew about it. So this is Google's, this is a result of many years of their experience. This is not what they use, but it's a product very similar to what Google uses. And you cannot really go wrong if you want a centralized management of your cluster. Kubernetes is the best of the best when you want Docker containers. The only problem with Kubernetes is that it's centralized, meaning that your developers will have no benefit from this, right? Because they cannot run it on their laptops, they cannot do anything. It's for centralized management of your cluster, meaning one guy does Kubernetes stuff. Other than that, really good. And finally, the whales thing, Swarm. A new kid, meaning that nobody knows whether it really works or doesn't. There is no proof. But if it will work, it will be probably the good choice. That's true. Now, I need to stop kidding. It's really good, but the major difference between Swarm and Kubernetes is Kubernetes gives you everything out of the box. Swarm is like a Lego box. You need to construct your own cluster by yourself, which has benefits and downsides. If you construct it yourself, you know that it does what you want it to do because you put all the pieces together. With Kubernetes, it does whatever Kubernetes wants to do, so if you like it, great. If you don't, can I say screwed? You're in a bad situation. Real-time registry. Any of you using Java? I'm sorry. Again, it's not the type of tool you write in Java. It's very old. API is terrible. It's still most used. So if you want something proven to work in production, this is the thing. Otherwise, stay away from it, because those guys are really cool. etcd and Consul. I think that tomorrow you will have a keynote from one of the guys from HashiCorp. He will speak about this, I think, more. Those two products are designed to be very dynamic. You run it across your whole server, whole cluster in all servers. You will never ever lose any data, simply because data is distributed continuously across all the servers, and it's a very cool thing if you want a place to do service discovery, actually to store data dynamically generated all the time. Historical registry. The guy outside with the boot, Elastic, told me that I cannot mention any other products, so go with Elasticsearch. No, that's the only one I used. There are others, Solar, for example, that are, and many others that are really good. And no matter which tool you choose, it needs to be in memory, because if you want to monitor your system based on this data, it needs to be like this instant, and it needs to have very powerful API. If it meets those requirements, choose anything, Elastic or something else. As I said, those guys, I'm sorry if I'm offending somebody, need to die. They need to disappear. Cannot handle actually the needs that we have today. Again, if you want good stuff, dynamic, very dynamic, made for cloud, go with Consul. Consul can do health checks apart from acting as a registry. And Kibana, if you really, really like spending your time in front of monitor and seeing things, oh, it goes up, and now it's down. If you don't have anything better in life, use Kibana for monitoring. Otherwise, Netflix is a much better alternative to Kibana, really. Works much better. At least I get more entertained. Kibana is good if you want to search through your logs and other stuff, but specifically for monitoring, Netflix is a better option. And I'm not talking about Netflix solutions, I'm talking about Netflix television. I would be forced to leave my company if I don't say Jenkins. No, Jenkins, you need something that is going to tie all those things together, some general orchestrator. Jenkins is one of the few tools that is widely used, and it's open source, so you know that you don't need to pay until you grow very, 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 very big. So general orchestration that ties all that together is Jenkins. And in my defense, I made this presentation before I joined CloudBees half a year ago. You can check it on YouTube. I said Jenkins even then. So that was, am I too fast? Yeah, I am a bit too fast. That's good, because we can go through many questions then. This is my blog, if you want to read it. This is the book, if you want to buy it. And questions. Anybody? I finished early, so only so that you can ask questions. Otherwise, I would speak something else. Yes, please. I have no idea what you said. Prometheus, I personally haven't used it, so I cannot comment. There is a tiny problem with what I do. I haven't used all the tools in the world, so I heard very good things about it, but no experience. It's devastating to admit, but it happens. Okay, some other questions, something that I did use, or you're speechless, no? Sleepy, something, yes, please. Data migrations can be very easy or very hard, and that mostly depend. Okay, I'll repeat the question. How do I deal with data migration when doing blue-green deployment? That was the question, right? The first counter question is, how long are your iterations?
It's about 1.
Oh, that's already long. No, the thing is that the first rule is that assuming that you have enough tests, right? That you're good with testing. Because if you're not good with testing, there is no point going that far. You cannot skip stats. So let's assume that you have enough tests of all kinds to verify stuff. And let's assume that your iterations are relatively small, so that you can change your schema so that they're always backward compatible. That's the rule. It needs to be backwards compatible. Similar rule like what you're doing with APIs, right? APIs are not really backwards compatible, but they can handle both old and new through different versions. Same thing with the database. A simple example would be, let's say that your next release should remove a column, right? You don't want to do that. You want to postpone removal of that column for maybe couple of releases later. It's just that you need to make sure that your schema between two versions is backwards compatible. And I always get the same question, so not the first one, and I think it's not as hard as people think. I think that database migrations tend to be painful usually for two reasons. First, if we have long iterations, and when I say long iterations, I mean really long iterations. I don't mean, oh, my development team releases every week, but my DBAs release every half a year or something like that. I mean short iterations, and if your DBAs are not a separate team. But that's a rule for everything, that I think that we need to move towards Amazon's concept of two pizza teams, that we have small teams capable of doing everything. I had a couple of cases where database migration was painful, but couple of many. Now, of course, if you bite the bullet and then go for NoSQL, then that suddenly becomes even easier. I don't know if I answered your question, but yeah? Okay. Anybody else?
Out of all these tools?
Okay, I'll repeat the question. No, I didn't touch it.
Out of all these tools that you mentioned, are there any which you could name, could be used for self-healing? Anything that helps you in doing that stuff?
Yep. So the question is, out of any of all those tools that I mentioned, if any can be used for self-healing, definitely. First of all, Consul. Consul is my preference today. I change my opinion every week almost. It happens. But Consul is really cool because it allows you to store data the same way as Zookeeper and etcd does, but it has incorporated health checks in itself. So you can tell Consul, okay, no matter I want to monitor service X. Use your own data that is auto-dynamically generated all the time, and do this and that type of checking. Console, is this what you're looking for? Yeah. Console does not have any pre-made solution. It just gives you a mechanism, say, you can do HTTP request, execute script, run something inside of a container, and do TTL, time to live. And TCP as well, yes. So is it 5 then? And you need to program it yourself. Now, some people don't like that approach. That's a similar distinction like between Swarm and Kubernetes. I love it because it gives me much more freedom than if things come out of box. It's very simple, very fast, and it's not going to heal anything. It's going to detect the problem, right, only. And when you detect the problem, it's your responsibility to tell him, okay, when you detected this problem, invoke this job with Jenkins, or run this script. Run something external that's going to fix the problem. And fixing the problem usually is redeploy something, right? Because if you have 3 servers, 1 server is down, redeploy will redeploy to the 2 healthy servers. It's relatively easy with Swarm, Kubernetes, and Mesos. On the other hand, where are they? Those 3 guys, those 2 guys, and starting a week from now, when they fix some bug that they had in the last release Swarm as well, we'll be able to already have mechanism to redeploy things without you doing anything when it fails. So they can make sure that a certain number of containers is already running. What they cannot do, and that's where proactiveness comes, they cannot decide when you need more or less. They will maintain status quo no matter what happens to your cluster. Yes? Vault. Yes, so the question, correct me if I'm wrong, is when things are happening auto-magically, how do you make sure that things continue being secured, right? To keep, on one hand, to keep things secure, like encrypted, let's say, and decrypted and needed, that's Vault. Another one from HashiCorp. There are other solutions as well, but since we are becoming HashiCorp fans, let's say Vault. And also, I think that it's interestingly, apart from normal things that you always do, kind of only port 80 and 443 should be open and things like that. I think it's becoming even more secure than before because there is no even SSH anymore. Nobody can enter a server. Not because nobody knows your password, but because there is no SSH to a server. Or at least it was maybe at the beginning when you need to provision the servers, and after that, just remove. So your servers are becoming less accessible simply because there is much less need for you to access as a human being the server, not other human beings. Any other questions? Not a single one. You're free to go then. But I know that you want to ask the question because nobody's leaving. It's a thing of the past. Why do we need it anymore? With containers, containers do not solve all the problems. It has a monster that, no, it doesn't. Maybe I have a certain level of competence with Cloud Foundry that might not be high enough to enter into deep discussion. But what I want today, no matter which is the solution, I just want a solution that is capable of creating new virtual machines, assuming that I want virtual machines, because that's also questionable as well. I might want to run on bare metal, and then there is zero need for that. And if I run on somewhere on public cloud, then I definitely want something to create virtual machines, but then I have API of Azure or AWS, et cetera, et cetera. It's a great thing, but again, I think that it's similar. I see them in a similar light like tools like Chef Puppet and Ansible, right? Now, I'm gonna just to make a parallel, and I hope you understand what I'm meaning. That all those tools are very useful still today, but the scope of what they're doing is much reduced. Like with Chef Puppet and Ansible, I'll use it only for infrastructure. I don't use it to deploy anything because there are better ways to do it. And the same thing with Cloud Foundry. If my applications, not all, but most of them are in containers, what should I do with Cloud Foundry except maybe create virtual machines? But that's probably not the main reason why you have it. No? They're fighting in a way. And I was involved in it was actually last week, and it was in Germany, and I cannot say the company. But yeah, we were setting Cloud Foundry, and it was kind of like, yeah, we want to use Docker, we want to use Cloud Foundry, and what should we do with Cloud Foundry? I don't know, let's do something. But that's my opinion. Cloud Foundry, I love you. Don't ban me from Germany. Any other question? Mm-hmm.
What do you do if there's something happening which you don't have monitored still, existing monitoring or in your logs?
Can you give me just more concrete, like example to work on? Your application is down.
I don't get the example of monitor your CPU.
I mean, if you don't monitor, then you need, if you don't monitor, you mean, if I understood the question.
You don't know why it stopped working, so you have nothing on your logs and on your monitoring which gets into the direction why it stopped working.
Kill it. Kill it.
If it happens next time again,
Destroy. If it happens next time, but I mean, that's why you are testing things, and you should investigate in laboratory and whatever you call your servers that are not production and things like that. You should make sure, try to reproduce the situation, but it's too expensive to go and then just try to figure out there. I assume in all this talk, for example, that all your logs, without any exception, are, for example, in Elasticsearch. So logging is not a reason to log in there, right? I assume that metrics from your hardware are also in Elasticsearch or somewhere else in a database. Now, if for some reason logging stopped working, and so there is no reason to go to a server to check the logs that don't exist. Kind of pointless in the first place. There might be cases, I'm not saying no, I might sound a bit too radical. There might be cases where you should log in into a machine, but not very often, if ever, I think. Especially imagine if you're talking about, let's go to extreme. Let's say Google size, right? I don't know how many thousands of servers they have, but it's thousands, a lot, right? Whatever, from machine to figure out which one failed. You need a lifetime, I think, when you go on a big scale. Now, when we're talking about 3, 4, 5 servers, then that makes sense. SH, maybe. Did I answer your question? Any other question I might answer negatively? Yes, please. Yes.
I'm not sure about the experience with Predictive are, but you can set their resource limits for CPU and
Yes.
memory. And the behavior of Kubernetes is that it kills a pod and exceeds these limits.
Memory or memory?
Pod, I think, or I'm not sure.
Memory.
Yeah. Do we have a tip how to determine the ideal limits for a pod for a container?
That depends on what's inside of container. Sorry, let me repeat the question. In Kubernetes, when you run a container, correct me, when that container exceeds the amount of memory that, for example, or some other restriction that you set, then it dies, right? First of all, that's the behavior of Docker itself, not Kubernetes. Any Docker container that has a set memory limit will simply shut down if the application inside of it or service exceeds that limit. So it will work the same no matter which of the tools you do. And that's simply because containers isolate processes. They don't isolate physical resources. Containers do not isolate memory, CPU, and stuff like that. And that's the current behavior of Docker. Now, the second part of the question was, how do I determine how much memory to use? That depends on what's inside, right? What's inside of container. It can be a simple application, hello world, that with 100K can run forever. Or it can be, I need to change from Java, .NET, for example, that will die very quickly because it uses a lot of memory. So it really depends. I don't have any answer because it depends what's inside. But it's a bit of a problem because if you don't go very careful and if you don't monitor things, then you can easily exceed the limit. Java is, for example, a problem because Java virtual machine inside of container thinks that is the only thing running on a whole server, so it might easily schedule its memory thinking that it's the only one, does not understand the connotation of containers. So with all those, with JVM and .NET as well, you might want to go very careful with containers because they don't know about how to behave inside it. I mean, they know, but not as well as they should. 7 minutes. Yes, please.
You mentioned that you use console as a self-healing just to check if the
Yes.
container is stopped or not. You have console also running on the machine that is running Docker, for example, in each machine, or it's possible to do this check for another host? How it's?
Yeah. Okay, so the question is, since I use console as part of healing, monitoring, stuff like that, whether I run it on the same server where services are or somewhere else, right? You can run it wherever because, first you can run console wherever because it will receive information from your services through some other process, and doesn't matter if it will ping the service on the same server or service somewhere else, right? And even if it's running on the same server, when that service changes, it will ping somewhere else. So it will ping wherever. But you should always run, hopefully you should run console in all your servers. Because console occupies almost no resources, so you will have no penalty of running console everywhere. And console will make sure that data is distributed always throughout all instances of console. So if you don't want to risk loss of data, then you just run it on many servers, and data will be synchronized all the time. And then you know that if one server dies, doesn't matter because other servers all still have console. If you centralize it in one server or even few servers, what happens if those servers die? You lose your data. Now, of course, I would not run Oracle database on all servers because Oracle database occupies a lot, but this is minuscule. When you look at the processes and memory it uses, you will hardly notice that console is there even. It's very, very efficient. And one of the reasons why it's very efficient, and that's one of the benefits of microservices, I think, because it does one thing and one thing only. In this case, two things and two things only. So you don't get a big thing doing much more than you need. You get exactly what you need. If you need more, then you need to combine a couple of tools. But across the whole cluster is the answer. Or at least a lot of them. At least 3, always 3 for quorum. You can go if you don't have questions. Or if you have questions, keep it for Thursday. Some of you have a workshop, I think, with me. No? Nobody? Nobody likes me. Questions? Take 1, take 2, go.